Hello everybody. My second talk is about modern JavaScript. Just a reminder for those who didn't see me yesterday. I work for the company called Farata Systems, and my recent books are, I co-authored it actually with my colleague Anton. The latest one is TypeScript Quickly. This is the language that I like today. But things change. So we'll talk about JavaScript, the modern version of JavaScript as we use it today, as we know it today. Since most of the audience on this conference is Java developers, most likely you don't like JavaScript, right? So what are you doing here, basically? Yeah, I will convince you. All right. First of all, I don't like JavaScript either, to be honest with you. But things are changing. And how do they change? JavaScript was created within 10 days in 1995. And then it was evolving for some time, and then it was not for many years. And starting from 2015, the standard authority called ECMAScript, they decided to release new spec for JavaScript every year, annually. So it's called TC39, right there at the bottom. And starting from 2015, they started to release specs with new syntax, with new feature. The major changes in that spec were introduced in 2015. Basically, older version of JavaScript, or let me put it this way, most of the applications, most of the websites that are in production today, they use version that is called ES5, ECMAScript 5, all browsers supported. Starting from 2015, they started introducing new features. So ES6 is also known as ECMAScript 2015, ES7 is 2016, and so on. And now they say ES next to represent the very latest version of the language. And as you can see, in terms of support of the syntax, this is ECMAScript 6. No surprise, who can guess which browser doesn't support? Exactly, IE 11, right. And it's expected. But even if a browser doesn't support ECMAScript 6, you can still use its syntax, but you will need to use some polyfills, like replacement little pieces of script that you would add to your app, so the syntax works. So it's pretty safe to use it even as is, with polyfills. But now let me go over some changes in the syntax, so you will see what it brings you, and hope you will like it much better than before as a Java developer. One more thing I want to tell you, I am using TypeScript. TypeScript is much closer to what we know in Java, but TypeScript compiles into JavaScript. JavaScript runs in the browser or in Node.js or in any engine. That's the plan. And some people say, you use another language, so now we need to have an extra step. We need to compile from TypeScript to JavaScript. For that, I can tell you that you cannot avoid it. Even if you will say, you know what, I will use ECMAScript 6 or 7 or 8. If you want to make sure that all browsers support the syntax, you still have to compile it. And there are compilers that would compile from ECMAScript 6 to ECMAScript 5, for example, and so on. Anyway, let's talk about some of the syntax constructs. Var is a standard keyword in all versions of JavaScript to represent a variable. You say var and the name. But now there are two more keywords, let and const. Now let's see what's the problem with var. This is older ECMAScript 5 syntax. I declared customer and I initialized it with Joe, and then I have a function. Actually, it's iffy. You see this extra parentheses. Right, immediately executed function, extra parentheses, and these two, right? So it'll be created in memory. And then inside, I do console log. For those of you who don't know JavaScript, it's like system out println. right? So what I print inside the function customer, then I have this block. If true, I assign Mary, and then I outside of the block I want to print the customer as well, and then outside of the function I want to print the customer. So what this code will print? Any idea? For what will be the first? This number one. What would do? Some people say Mary, some people say Joe. I am not sure this is correct. I mean, this is not Java, guys. It's not as easy as Java when you read the code and you exactly understand what's going on. All right, so let me do this. On many slides, I have this link. If I will click on it, you will see this example running. I use this nice tool called CodePen. You can run the example. Look down there. This is the console. So number one is undefined, right? It's not what you thought it would be. Why? Because JavaScript has something that is called hoisting, variable hoisting. You declare a variable and its declaration goes up to the top. In this case, I had variable customer. I initialized it with Joe. At this very moment, it seems to be Joe, but I declared another variable customer again. So its declaration was hoisted to the top. Initialization is not hoisted. So this declaration overridden that declaration, and it's not initialized yet. The other thing is, as you saw in there, by the way, the name of the customer side of the function is Mary, and then Joe. So what did we have there? Look, this print statement is outside of this block, right? So in Java, it wouldn't see Mary. In JavaScript, ECMAScript 5, it doesn't work, so it still can see it. So there is no block scope support. That's the point. So const and let allow you to introduce block scope. Const is for variables that can be initialized only once, like constant, and let is for any other variable. What we recommend, or I recommend, use const all the time. Declare something, the identifier as const. And then if you need to change it, then switch it to let. So with const or let, you have this block scoping. In this example, it would print Joe here. What it would print over here for number 2? What? Joe. And for number 3? Joe, exactly, you're right. I will not even run it because you already know. See, we have this local block scope. Inside the curly braces, you can declare a variable in this local scope. Next, nice little feature in ECMAScript 6. By the way, ECMAScript 6 introduced majority of the changes. ECMAScript 7 or 8, these are minor things. So, template literals. Look at this string. It's not a single quote over there. I don't know if you can see that. It's a backtick on the top left corner of your keyboard. When you use backticks, you can put in there template literals. First of all, you can inject in their variable name using $ and curly braces. And also, you can use multi-line strings. If you have a long string, you don't need to concatenate all these pieces on multiple lines. It's very useful if you deal with HTML, for example. You need to write a piece of HTML, multiple lines. You can put backtick and then several lines of code, format it as you want, and then again backtick. This is a really nice little feature. In Java, we have lambda expressions, right? Now, ECMAScript 6 introduces these lambda expressions in JavaScript. So first of all, it's a shorter notation for anonymous functions, like in Java, right? So similar idea. And not only it makes the syntax shorter, but it also introduces lexical scope for this. Let me explain you what does it mean. So let's go down actually, from bottom up. In ECMAScript 5, we declare the variable sum and we say it's a function with arguments and it does something. I didn't give a name. After the word functions, there's no name, right? That's why it's an anonymous function. We assign it to this variable, and we can invoke sum with parentheses with 2 arguments. The syntax that ES6 introduces, they introduce this fat arrow. We call it fat arrow expression. In Java, it would be single dash and then greater than, right? Over here, it's a fat arrow. So it's very similar. Just get rid of this word function, right? And if it's a single line, you don't even need to write a return statement. So this fat arrow functions, they are simpler to write, and also they introduce lexical scope for this. And what does it even mean? It's probably will be on the next slide. On this one, I'm showing you that you can pass around, like in Java, you could pass a lambda expression as an argument. The same thing in JavaScript. Like in this example, I have an array, and then I say the sum of array is my array.reduce. Reduce is a function, standard function on arrays that allows you to pass another function to aggregate the value of the array the way you want it. Like in this case, I'm saying take every element of the array and add them up together. In this case, it's filter, right? I have an array, filter, and I pass lambda expression. It's a predicate, right? This expression, what does it do? What does it do? Who knows? Checks for what? Even, correct. This is a module, right? Like in Java. Do you remember Java? You had these Java puzzlers, right? Yesterday. So yes, just it says filter out only those that are even. That remainder of the division by 2 is 0, right? Anyway, so you can pass them around. And now let me explain you the problem with this. Java developers are spoiled with this keyword this. Why you are spoiled? Because you know exactly where this is pointing at. If you are inside the instance of the object and you write this dot something, you know what it is, right? JavaScript developers didn't have this luxury for many years. Why? Let's take a look at this example. I have a function, stock quote generator. You will pass me a symbol like IBM, Microsoft, whatever. I assign it to this dot symbol. Then I use set interval, right? I want to repeat this code every 1,000 milliseconds. Every second I want to execute this function, right? And it's supposed to print the price of this dot symbol equal, and I use a random number generator to generate the price as if I'm getting the price for the stock, for example. So what do you think it's gonna print as a symbol if I will invoke it with IBM? Undefined. That's exactly right. Are you a Java developer or you're a JavaScript developer? You're not a Java developer. Full stack, right? Java developer is supposed to answer IBM, which would be wrong. Why it is wrong? Because we are losing the context of this because set interval is executed asynchronously. There is something called event loop, and this, because of set interval, you're saying in a second, asynchronously, later on, execute this code. Later on, this is going to point at the global object. If you run it in the browser, it'll point at the window object. The window object doesn't have a property symbol. That's why you're going to see undefined. See, depending on how you invoke the function, you may or may not have this variable pointing at what you think it should. So in JavaScript, in older version, people found a solution. They see in here, for example, I declare the variable that, I remember that, and then if I will do it this way, then it'll be IBM. It'll remember that. You have to remember. If you want to learn it, just Google this and that problem in JavaScript. You will see description and everything. With fat arrow expression, you don't have this problem anymore, starting from ECMAScript 6. Look at this example. The same example technically, but over here, I'm using fat arrow function instead of anonymous one. Let me go back a slide. See this? In this slide, I use anonymous function. Actually, it's not even anonymous, but I'm not using the fat arrow expression. In this case, I do use fat arrow expression. and it preserves the content of this. So if I would run this example, it would definitely print IBM over here. It's an important thing, so lexical scope for this it was introduced. Next thing, new operator called REST. It's for if you want to invoke a function with variable number of parameters. You can put these 3 dots in front of the last argument in the function, and it'll give you an array. So basically, let's take a look at this function. I have a function called calctext, which has the first argument as an income, and the second argument is REST operator, 3 dots and customers. What I'm saying, give me the first argument as they will invoke, but the second, or I don't know, maybe third or fourth, all other argument place in the array and give me that array. And I want to refer it as customers. So in this case, I'll print calculating types for customers with income. This is the first argument, right? And then I use for each. It's a standard operator in JavaScript. For each element in the array customers, I want to do something. I want to print it out. And then I invoke these 2 functions. Calc tax 50,000. Let's say I want to calculate taxes for these 3 people, 1, 2, 3. And I want then again to calculate taxes for these 2, Olson and Clinton. Even in ECMAScript 5, there was a special thingy called arguments, if you would pass many arguments to the function. But it was not exactly an array, and it has some special inconveniences. Now you get an array. Let me click on this link, and you will see that. In this example, I think I call first, I show you the ECMAScript 5 syntax or version. And then I show you the same thing, but ECMAScript 6 version with the REST operator. And on the console, you will see that both these examples work fine. So like in this case, in ECMAScript 5 processing Smith, Johnson, McDonald, and so on. And in ECMAScript 6, the same thing. But syntax-wise, ECMAScript 6 is much cleaner, right? 3 dots, and that's all you need, and you got a clean array. In case of ECMAScript 5, I would need to do these special tricks to get an array. So nice and simple. Spread operator. It's also represented by 3 dots. I don't know why, to be honest with you. They don't have imagination to come up with something else, or maybe to confuse people. But it's also an operator, but it does different things. If REST operator would take multiple values and put them together into an array, the spread operator does the opposite. It takes an array and spread it apart. It gives you individual elements. Really, really cool operator. I really like it. So it turns an array into a list of individual values. Let's take a look at this example. See, this one-liner uses push. Push is a standard JavaScript operator. Let's say you have an array, and you want to take elements from array 2 and copy them over into the array 1. So I have array 2, but the push function assumes that I will give individual elements, right? So these 3 dots will do the trick. It takes an array, extract all these elements as an individual, and I give it to the function or method push. If you want to create a copy of an array with the spread operator, also very easy. In JavaScript, as soon as you put square brackets on the right side of the equal sign, you create an array. But what do you want to put inside the array? Look at this. Let's say you have some my array with some elements. I'm saying take those elements, extract them as individual, and put them in this array. One-liner copies elements from one array to the other. Easy. For example, finding a maximum element. When you read the API, the max function assumes that you're going to give several individual elements, right? So what do we do? If you want to find the maximum value in that array, I'm saying turn it into a list of individual and then apply max. Easy. Another example, cloning. If you want to clone an object using spread operator, it's easy. As a matter of fact, there is the older way, I don't show it over here, but the older way would be to use a special function, assign, object.assign, would also clone. But this syntax is more simple. Let's take a look. I have an object, my object. By the way, in JavaScript, you can create an instance of the object using so-called object literal syntax, curly braces, instantiate an object, and then whatever I put inside. So the first line creates an instance of an object with two properties: name with the value Mary, and last name with the value Smith. So that's an instance of the object with two properties. What if I want to clone it? Look at this. I put curly braces, means create for me an instance of a new object, right? This is in template literal. And then I say, take the objects that I already have, this one, spread it apart, extract all the properties, and put them there. So this creates a clone. Moreover, you can do cloning with modifying specific properties on the fly. Let's take a look at the second example. Similar to the first one, but look at this. I create an instance of a new object. I pass the existing object, my object, and also on the fly, I want to replace the value of last name. It used to be Smith on top, and I want to change it to Lee. In one liner, I do all that. Let's see if it works. Click on the link. And it does work. By the way, on this link, I showed the older syntax using object assign, but then I show you the newer syntax, this one. At the bottom, you will see that it creates an instance of the with the last name Oxford, property Oxford, and the name is Mary. What did I have before? What did I have before? I had Mary Smith. Now I do cloning, and I have Mary Oxford. This is important in JavaScript. In general, in JavaScript, everybody is concerned with mutability. Things should be immutable, non-changeable. Especially it's important when you want to maintain a state of the application, state of the app. In many different frameworks, they are worried about how do we maintain state. I can give you an example why it's a serious problem. I don't know if you guys face this problem, but think of it this way. You create a web app. This web app runs in the browser. These days, we create complex app which may or may not be so-called single-page app. Meaning what? Meaning we downloaded the app, all JavaScript is here. I don't make requests to refresh the page. I don't need it. I can change certain pieces inside the page, but not the whole page. I don't need to refresh the page to bring the code again. I already have it here. Now, the user navigates within the app, and obviously, you may need to remember where the user went before, what variables they changed, state. I was working on a project last year for a company, for a large European company that makes, let me put it this way, luxury cars. And they were, actually it was a Vans division, Vans. Really cool company, of course you know that company, but you need to be a very senior software engineer to buy these cars. And they have 1,700 different configurations for the vans. It could be transport van, it could be for craftsmen's, it could be all these different things, different options. So you go to their site and you select, configure my van. You select, I want this chassis, and I want this engine, and I want it to be this tall. And then there is another option in the menu. Upgrade. Select upgrades. And what happened is, like, you probably saw that large app, when you look at the code, it looks like everybody who entered the building wrote something in that app. Their own style, absolutely different. In one case, it was pure JavaScript. Then there was a piece in AngularJS. Then there was a piece in React, HTML, different templating engines. And the business requirement was, if you upgraded the van on this page, you want to be able to click on the next link and remember what did you select already, so you can keep adding features to your van. Simple, right? It is simple if from the get-go you would worry about the state management and if you would remember the state. But state management was done in absolutely different ways. In some cases it was a piece of parameters in the URL. In some cases it was local storage in the browser on the disk. In some cases it was done using AngularJS, older one features through controllers. And then all of a sudden there is a React piece. In React piece it's a different way of selecting state. So because of that, the app becomes so complicated, you cannot even imagine. So my advice, if you will work regardless of what language do you use, on large projects, state management is important. So why did they tell you all that thing? These days, if you worry about state management, we want it to be state to be immutable. So every little page on the UI changes something on the state, but it's not changing actually. It creates a new object, but the old state survives. So these kind of operators like cloning are important because you need to clone objects instead of updating them. Destructuring, really cool feature. It takes the object or an array apart into pieces. Much easier to extract only those properties that you care about. Well, let me show you. Look at this function. I have a function getStock, and this function just have one statement, return. And it returns an object. Once again, it's a template literal, curly braces. I create an object with three properties, symbol, price, and shares, and I return it. So whoever calls this function, getStock right there, would return me an object with three properties. What if I need only two? Of course, I can get the object into a variable, and then I can pick the only one that I need. But with destructuring, look at this. Curly braces on the left side of the equal sign. I get the object and I destructure it. I rip it apart. So in this case, as you can probably guess, I care only about symbol and price. So this one line declares two variables. One of them is symbol, the other one is price. It extracts these values from the object and assigns them to these two variables. Nice and very, very useful. This is an example of destructuring in the browser. Imagine that you have a button somewhere on your UI, and you want to add event listener to the button, right? In the browser, when an event happens, these DOM events are being generated and sent over. DOM event has many different properties, but you don't care in this one. In this case, I just want to know which button was clicked. Maybe I have 5 buttons on the screen. I want you to know which one. And it is represented by the property target of the DOM event object. So what do? I say, I want to add event listener. When somebody will click on the button, give me that object and destructure it. Extract from it the property target and just give it to me, just one property. Nice and simple. And I have this target in this variable. These curly braces. Whenever I see curly braces on the left of the equal sign, it's destructuring. Classes. ECMAScript 6 introduced classes, and you can use inheritance. To be honest, under the hood, JavaScript or ECMAScript still uses different type of inheritance, which is called prototypal inheritance. And this is what is shown on top of this slide. So let's say I have a function tags. This is an older syntax, ECMAScript 5. I have a function tags, then I have a function New Jersey tags, right? And I want to say that New Jersey tags should be a subclass. There were no classes, sub-object of tags. In older JavaScript, and actually it's under the hood, they support like object inheritance, not class inheritance, but object. During the runtime, you decide this is an object and this is an object, and it's my daddy now. Daddy of this object. During the runtime. And there is special property prototype, and see, we create a new object tags We assign it to the prototype of an JText, and this is how we say, this is your daddy during the runtime. Now we instantiate a new JText, and it already knows that I inherited from text. This is how it was. In case of ECMAScript 6, you have standard syntax like you are used to in Java. Class text, and you declare your properties and methods in there. And then they allow you to use keyword extends. Very similar to what you have in Java. Constructors in classes. A little different, but the idea is the same. Constructor is invoked only once when you instantiate the object. But if in Java you would just use the method, you would give it a name the same as a class. In here, in ECMAScript 6 or newer, you just have to use this keyword constructor. The rest is the same. It's a constructor. Now let's talk about asynchronous calls. Callbacks, promises, async-await. Before even going there, let me tell you something about the JavaScript as a language and about asynchronicity of this language. JavaScript as a language is single-threaded language, period. So if you started invoking a function, the function goes on stack, and if from this function you call another function, it goes on stack on top, and until this function is not over, it'll sit there. Then it pops from the stack, and the execution continues. Synchronous execution. But there is JavaScript engine, and there is something else. And what is it? Something else. If the JavaScript engine is running in the browser, there is Web API, one thing, and there is event loop. If the JavaScript engine runs under Node.js, standalone, server-side, desktop, whatever, same thing. You have JavaScript engine, you have a piece of the API written in C or C++, and you have event loop. So wherever JavaScript engine is running, remember it has a call stack with single thread, there are other places. By the way, I forgot about one more thing. And there is also a message queue. Message queue. We'll talk about it. So you start the program, it starts the execution of the JavaScript code, but we don't want the execution of the JavaScript to block the rest of the app. What if I make a call to a JavaScript function that does image recognition that takes 10 seconds, for example? We don't want the user to sit and wait. We want the user to keep working with the UI, for example, right? So what we do, we use a set interval, set timeout, and we use callbacks. I'm saying set timeout, for example. Invoke this function in 1 second, in half a second, in 0 seconds, but on the next iteration of the event loop. Event loop keep running outside of the engine. It tries to see, do I have anything to execute? Is there any in the message loop for callbacks or no? Keep running, keep running, keep running. If I will say set timeout function that does whatever, let's say image recognition, it executes that function, it starts executing that function, but the event loop can proceed, can continue, so there's no blockage. At some point that function will be over, and the result will be placed in the message queue, and that event loop will pick it up and continue. By using this architecture, they do amazing things. We, Java developers, are very proud of ourselves that we know multi-threading, right? We know how to make the code running in parallel. Then we run into all these problems with locks, right? With race condition and stuff. But in JavaScript, they didn't have this in the first place. They said it's a standard, it's a single-threaded language. But using this architecture outside of the JavaScript engine, event loop and asynchronous callbacks, they achieve really great performance. Node.js as a server, you'd be amazed to see how many user requests they can handle. They get a request, they put it aside, and eventually when the request is back, it goes back to the message queue, and it will be taken from that message queue. So, and there's no way that you will run into these locks, into these race condition in there. Anyway, callbacks. I told you about the mechanism behind this set timeout, but the syntax-wise, it was really ugly. I mean, it's very hard to read code that looks like this. In this example, I am using set timeout just to emulate some long request to the server. Set timeout, I said, actually the whole function is get product detail, right? And then I say set timeout function, and I put print getting customers. Imagine that actually it's not a just print, it's just a request to the server to get customer. When I'm going to get customers back, I don't know. It's a long call, maybe a synchronous call, but at some point I will get customers back. So what do I say? What do I say? And when I'm going to get customers back, again, I give a callback saying getting orders, right? Let's say I got customer 1, 2, 3. Sometime later, this second callback will be invoked, and I give to the second callback the third one. I'm saying getting products for this order. What are the products in this order? So when you look at this code, it's a short example, but even this example is difficult to read. Agree? Difficult. People started to say it's a callback hell, especially on larger app. Code becomes unreadable. Some people call it a pyramid of doom, because this looks like a pyramid, right? The code looks like this. It's hard to read. So what happens next? Again, we are talking about asynchronous code. As a matter of fact, we can click on this little link, and you will see this example. In a second, look down. See, in a second, it says getting customer, getting orders, getting products, getting product detail. 4 callbacks, 1 second apart. This 1,000 milliseconds means 1 second, right? So this code works, but it's hard to read. So what was the next step in the evolution of these asynchronous callbacks? Promises. Promises. Promise is an object that represents eventual completion of the code. So when you invoke something asynchronous that will come back later, you get the promise right away. You got an instance of this object, and then something happens somewhere. Eventually, this place somewhere can either resolve or reject, meaning it can either successfully return and give you what you expect, or it can throw you an error. And they introduce this keyword then, actually the function. So you say, I want to create a new promise, and then you chain, then. Instead of callback, you say, do this. Whenever it comes back, then do that. Whenever this comes back, then do this. And at the end, you can write catch. Catch will catch errors, if any. The code became more readable after that, comparing to those callbacks and that pyramid of doom. Let's look at this example with promises. You have a function get customer, right? So what are we doing there? First thing we do, we say return new promise. Right away, the caller gets the promise object. It didn't happen, and we don't know if the promise succeed or no. But the referencer is returned back. And then I provide a function. I say, dear promise, here's a function for you. It has 2 parameters. If you can do what you are planning to do resolve and give me the return value. Otherwise, use the second argument to invoke and give me the error message, right? So in this case, I do something, I do set timeout to emulate the long processing, and then obviously I always do success for simplicity, and I return John Smith. Otherwise, that would return can't get customers. So, and down there, look at the bottom. So now I can do get customers dot then dot catch. This code is a little bit easier to read than those callbacks, right? And besides that, you can attach many then, like in the first example. get customers, then get orders, then get product details, then, and so on. So it becomes better than it used to be. But it's ECMAScript 6, 2015, right? But starting from ECMAScript 8, they give us two new keywords, async and await. But I'll show them to you later. At least let's enjoy promises for a little bit. Chaining promises. On the left, I have this function, get customers. I say new promise, right? And I return John Smith in my case. Then I have another function called get orders. Let's say I get a customer. I want to see what orders this customer has, right? So I have, again, get orders, assuming that we will get the customer as an argument. I create a new promise, and then I resolve this. I hard-coded everything, obviously, for simplicity. And then at the bottom, I want to invoke get customers, this guy, whenever it's over in a second. I want to print the result on the console. Then I want to pass this return customer to the next function, next asynchronous function, right? Get orders. Then I will get a result back again in a second, and I want to print it. And at the end, I put catch. So see, now instead of nested callbacks with that pyramid, this code down there is more readable. Let's see it in action. Let's see it in action. Yeah, see it down there at the bottom of the console. You saw the same output as with callbacks, 1 second apart, but the code that invokes it is cleaner right there, starting from line 40, this code. Right? So it was a step in the right direction using promises, ECMAScript 6. ECMAScript 8 introduces two keywords, async-await. Again, for the same reason, to simplify asynchronous programming. When I show you the code, you will look at the code and it looks to you like as if it's a synchronous code, but it actually is asynchronous. Easier to read. So you don't need to use callbacks. You don't need to use then. You just use standard try catch. So these are the two keywords, two new keywords. Async is just to mark a function, just to say that this function is asynchronous, that this function will return a promise. Await states, don't go to the next line in code until this one returns. These are the two keywords. And let's take a look at this example. I have the function again. I keep working with the same example, get customer and orders. I have a function get customers orders, and I marked it as async. Then I have try catch block. First, what I do is I say I want to get customers. I want to invoke get customers, but it is asynchronous, and I want to wait until it's done. In my examples, it would be 1 second, right? So in 1 second, I get back a return over here, and the execution continues. I print what I got. And then again, the next function, get orders. Again, I marked it as a wait, with a wait. So the next line will not be executed until the code completes. So as you can see, this code looks like a simple synchronous code, but it is asynchronous. And moreover, what is important, it's not blocking the caller. It does not block it because of that event loop that I explained you before and that message queue that is supported under the hood. So I click on that link. And it does this, it does what's supposed to do at the bottom, right? So what I did over here in this example, if you will decide to run it on your own, I have get customers. I return new promise, like before. I explained you with the promises. Then I have get orders. Once again, I return promise. And finally, at the end, I execute get customers as asynchronous. I say wait for me. Then I execute get orders, and they try catch. That's the code. So the code becomes much more simple. Code modularization. In JavaScript world, in the very beginning in 1995, programs were really small. the language was used to make nice little improvements here and there on the UI. I want to make some flashing menu, or I want to paint something in red, and so on. Easy. Now, these days, we have thousands and thousands of lines of JavaScript that are running in the browser. So the code becomes large, and then also you may want to use some libraries. So thousands and thousands of code are executed, and obviously it would be nice to split your app, the front-end piece, into modules, right? This ability was always there, but how would you do something like this? The easiest part would be to implement module design pattern. Actually, let me try to switch to a different presentation. I think I can show it to you. In ECMAScript 5, what would you do? You could implement module design pattern yourself, or you could use one of the popular libraries that offers you to cut the app into pieces and load portions of them. Require.js, if you know, this implements AMD standard. Node.js implements CommonJS standard. But let me show you how you can implement. Let's say you still use the old version of JavaScript and you would want to implement module design pattern yourself. See, I have a function. I don't know if I think I already mentioned that, maybe not. When you use these parentheses and one more pair of parentheses, it's so-called iffy, immediately invoked, immediately initialized function expression. So whatever code is there will be executed right away. You don't even need to call it separately. Now, if I will say variable shipping module, and I will use this iffy, what I create is, I create like a little shell encapsulated. What is exposed inside the browser, in the global space? This variable, shipping module. But whatever I will put inside will stay inside. It will not be visible to external code unless I'll do something. For example, over here, we want to ship some product, right? So look at this. I have, again, iffy to the variable. And inside, I have another variable, apply discount, and it's a function as well. You give customer name, you give discount to apply, and I just print it. But since it's sitting inside the iffy, it will not be visible outside. It's like a private variable in Java object. Look at this. If I will try to do something like this, shipping module dot apply discount, I'm going to get an error. It'll say, I don't know what you're talking about. I don't see apply discount. I didn't expose it. So what I could do, if I would say return and something, whatever I return will be visible from outside. See, again, I have this shipping module with iffy. I still have this apply discount, which is not visible from outside. I can use it inside, but not from outside. And then I say return, curly braces, template, literal notation, right? And I declare in there the function called Callbacks. And I check the customer name. If the customer name is Soprano, I give him 50% off for shipping. Otherwise, only 10% off. This is what will be visible from outside, whatever I put in red, right? But my apply discount function, yes, I can call it over here, but not from outside. Look at this, shipping module, calc discount Soprano, calc discount Smith. If you will click on this little link, you will see different discounts. See, giving 50% to Soprano and giving 10% to Smith. The same code that I showed you on this slide, nothing else. This, what did I show you? I showed you the way to implement, if you wanted to implement this module design pattern yourself in ECMAScript 5. But in ECMAScript 6, finally, they give you a nice syntax to cut your app into pieces. They give you two keywords, import and export. If you have a piece of code, you can put in there export this, export that, and something you will not be exporting. So whatever you export will be visible from outside. The rest is hidden inside. So technically, what is ECMAScript module? It's a file with JavaScript which has either import keywords or export keywords. Otherwise, it's not. So look at this example, class person. Let's say I have this class in the file called person.js. I have this code. If I will say let p equal new person, this instance will be created on the global scope. It's not module. It will be created on the global scope. If I will have multiple files like this and I will instantiate each of them, I will quickly pollute my global scope, being that a browser or Node.js. But with one little keyword, again, I have the file person.js, but since I am using expert keyword, it becomes a module. It's not a standard or regular script anymore. It's a module. And if I will try to instantiate new person like down there, it will not pollute the global scope. Let's say I have main.js, and inside main.js, I want to use code from person.js, right? I also instantiate new person, but that guy is sitting inside the module now, so it will not pollute the global scope. The variable p will not be created on the global scope. You can have named experts or you can have default experts. You can export as many variables as you want. Like in this example, I have text.js file, right? I export this variable text code. I export this function called texts. I do not export this function. Do something else, it becomes technically private. And I export this function. Pretty easy. Accordingly, in a different script in main.js, I can import these guys. So I can import only those that I exported somewhere. Like in this case, I only import text code and calc texts from .text.js. And I can use them. So this is how you can split the app into pieces. Also, there is something called default exports. You can use the keyword default. I export the function, whatever function it is, and I export this one. The second line with export is named export, and it can be imported only with this name. But in the first case, it's a default export. It can be imported with any name. Let's look at the main.js. See, in this case, I say import cool function. I decided to call it cool function. I'm saying whatever you text.js exports, by default, I want to call from now on cool function. On the other hand, if you use named export, I have to use this curly braces and the exact name as it was called in text.js. What they did with ECMAScript 6, they said, these are the keywords, use them. But they didn't put a standard how browser is supposed to load them if there are separate modules. And because of that, different libraries were created. One of them was popular, system.js, right? They created a way to load ECMAScript 6 modules. But now you don't need to use any of these libraries. They allow you to use this special keyword in type. See, this is HTML, for example. In HTML, you have script tag, which is a standard tag, right? And you can use, instead of JavaScript, you say module. And it'll understand that I need to load it, and it'll load the module. In this case, main.js, and it'll load the module shipping.js. Main.js is a module. Why? Because it uses import statement, import keyword. Shipping.js is a module. Why? Because it uses export keyword, correct? So things become pretty simple. And this is all I wanted to tell you. I will answer questions if you want. There are some links. Up on top, there are examples that I showed you today. This example I put as HTML, little HTML files with JavaScript pieces. My blog, email, and at the bottom I put a link. It's a new one, State of JavaScript. They published an article, nice article, 20,000 developers review, actual survey, and they answered different questions about JavaScript. So take a look at it. So you will see what is popular, what is not popular. And it shows you that only 5% of women are using JavaScript and so on. Any questions? Yes, please. I don't know if anybody has a mic. Oh, actually, yeah. Mic? Can somebody turn on the mic? Before they do this, I want to make one extra statement. Now think about it. The JavaScript is evolving. They keep releasing, and they say every year we'll release new spec for the language. But as you can imagine, browsers are not eager to immediately implement the very latest version of the syntax. It may take 2 years, it may take 3 years. But if you use TypeScript, you can use the new feature right away. They follow the standards and they implement them right away, and then you can compile them down to the older version of JavaScript. Okay, let's answer the question. Yes.
The question is about example with clone. Was it deep cloning?
No, it's a shallow clone. The question was, when you do cloning using the spread operator, is this a deep clone? No, it is not. It is shallow clone.
So what is the elegant way in ES6 to do deep cloning?
Deep cloning you can do, but you will have to write several statements. Maybe you will write several spread operators or several, or write a function that in turns it checks the syntax, it checks the type of every property, and depending on that, it make another clone.
Okay, so I have to do it myself?
You have to do it yourself, right?
Okay, thanks.
Hello, a little question about asynchronous calls. So if I publish, can I publish asynchronous function with, say, Express server in Node.js, or this is bad practice and it's better to use them in published methods?
No, you can use async-await with Node.js, and it's not a bad practice. Why would it be?
No, I mean if I declare in server endpoints, if function.
No, let me explain you. First of all, you need to think about it this way. Under the hood, you still have promises. Async-await just give you a more readable syntax. Also, if you wanted to do what I hear what you ask, if you have several asynchronous calls, you want to hit several servers, right? And then collect the result. There is promise.all, the function that can do that for you. So if you need to, you can still do this. But async-await you can use in Node.js just for readability.
So I can publish with get or post functions which is declared as asynchronous.
Yes.
Thank you.
First of all, thanks for such a great introduction to modern JavaScript. And you are right, I'm a JavaScript developer. Please don't blame me, guys. I would like to say about Node.js plus TypeScript. Is it a good choice for a backend? Could be a replacement for a Java on a backend?
I don't know about replacement for Java. You want me to scare you or something? You want to switch and learn something else? I don't know. Node.js is a really excellent environment, really fast. They can handle easily 65,000 simultaneous requests, Node.js server. And you won't need to worry about this multi-threading. In many cases, it makes sense to put a Node.js server, not instead of Java application server, but offload certain processing in the Node.js server, and the rest will go to Java. So you can do this easily. And what was the second question?
That was actually one question. What do you think about using TypeScript on Node.js?
Oh, the TypeScript, yes. TypeScript, we do use it. It's very simple. And the TypeScript doesn't stop you from using thousands and thousands JavaScript libraries that exist so far. TypeScript allows you to get excellent help from IDE and have a compiler. There are special files. It's not a TypeScript talk. By the way, tomorrow there is a community talk like Rockstar Night on Chrestiatic. I will be doing a presentation about TypeScript. So you can still use TypeScript and you will have compile time checking and you will have type ahead help. So it's excellent choice. We do this.
May I ask about another question, guys? It's okay. About TypeScript, is there something inside TypeScript which is not covered yet? Like,
what do you mean?
I mean, TypeScript is growing fast as a new approach in JavaScript communities. Is there something it still should be improved in TypeScript from your perspective?
It's perfect. No, let me explain. First of all, the creator of TypeScript is Andres Heilsberg, who created, by the way, C#, Delphi, Turbo Pascal. He knows how to create languages. B, they don't create this, they didn't create this language just to say, okay, let's do this. See, they implemented interfaces. They implemented something else, generics, and so on. But what they do is, they say, we will implement some extra things, which are cool things which people need, but we want to stick to the standard. If you think about this ECMAScript standard, they have phases. There is a proposal, and it goes through first phase, second phase, third phase, and then it make it to the release. TypeScript creators watch it closely, and if a feature made it to phase 3, they say, all right, it's pretty, the chances are high that it'll make it to the language, so they implement it today. See, so that's how they make it ahead. Keep it ahead. So it'll keep improving, but improvements will be done in two ways. A, they came up with some cool ideas and they want to implement it in the syntax, and B, ECMAScript 6 introduced new feature.
Thank you.
You're welcome.
Thank you so much for a great presentation.
Thanks.
So a question, you showed us that you can modules can have default exports. What is the actual use case for this feature? So isn't it a best practice?
It is not
a bad practice, because you showed us on import that you are just naming the first function is exported, and then you give it a random name. What is the use case?
The use case is, actually, I'm wondering that you are asking this question. It's a very interesting question. It is not recommended to use default export. Why? Because we use optimizers, we use extra tooling to optimize code. With default exports, they are confused a little bit. So I would say it's for lazy people who just want to say, I want to export one thing, and you name it the way you want it. On one hand, it gives you some freedom. You can say, I want to call it this thing Mary here, and there I want to call it John. But my opinion, it's not a big deal to use named export.
Same here. Thank you.
Thank you, Yakov, for a great talk.
Okay.
You mentioned a lot of good things about TypeScript, but is there any constraints that could block you from using it? Can you mention?
TypeScript? No. I can tell you that there are probably 100 languages today that compile into JavaScript. TypeScript is getting popularity leaps and bounds. And survey on Stack Overflow every year shows it's one of the most loved language. Every week they have 500,000 downloads from their central repository, Node.js. So far, everybody likes it. I am doing lots of trainings in the US. Most of my audiences are Java developers. They love it. Everybody hated JavaScript, but when they see TypeScript, they understand it right away. Classes, inheritance, private, public, protected, generics, interfaces. There are differences, but we didn't run into any. We work on a real-world project using TypeScript.
Could there be some situation when you're not able to use it?
No, it cannot, because TypeScript is a superset of JavaScript. What does it mean? It means that you have a JavaScript program. It's a file with extension .js. You will just rename it to .ts. It's a valid TypeScript program.
Okay.
So if it doesn't work in JavaScript, of course there could be a problem. Otherwise, no. Mm-hmm. Yep.
Hello.
Hello.
Yeah, you were right about the hell of this keyword for Java developers. And before this lecture, I was thinking that I already got through this issue. And I noticed on some of your slides about this keyword that there was a function which was using this keyword inside this function, and this keyword was referring to the function in which it was using to the
variable,
to the scope of this function that it was using. But inside this function, you were calling another. Oh, sorry. You were calling another function that also uses.
Yeah, but I was calling it using set timeout. It's very important. Asynchronous call. If only because of that, set timeout was invoked asynchronously. It placed it on the next cycle of the event loop. On the next cycle, this dot customers was not there. It tries to see who is this. This is window object, the global one. Is there a property customer? No. Done.
So let me just say what I'm thinking. So if you call some function, a synchronous function inside function which is not in which is in global scope, so this function, so this keyword relates to the global scope?
No, this will point at a different object. While we are in a function, if I wouldn't be using set timeout, everything would be fine. This would not be confused. But when I use set timeout, the message was placed into the message queue. It was invoked as a callback later.
Oh, okay.
Again, I don't have time now, but you need to imagine it's call stack. Main function, second function. And then I do set timeout. Set timeout will not be on the same stack. So that's the
Thank
problem.
you.
Could you say a few words about generators? Hi,
Oh,
here.
about generators.
Yes, and some real-life example.
I have an example. If you go to one of these examples, I have generators. Generators are the way to suspend the function for a short time. You have a function body, and you want to control, say you reach a certain portion in the function, and you want the caller, you want to pass the control to the caller. And then the caller will do something, analyze something, and then you can proceed, continue from within the function, from that last line of the execution. These are called generators. I'm not sure what I need to tell about them, but they are there. Yes, they are in ECMAScript 6. Yes.
Hello?
Actually, I have one more question because next speaker is
you
coming.
told that we can use thousands of JavaScript libraries from TypeScript and nothing stops us from using TypeScript. So I have a question. Is it possible to use JavaScript library from TypeScript if this library doesn't have TypeScript definitions defined?
Yeah, very, very good question. See, I didn't explain how TypeScript works, but apparently you already know. So let me then tell you. TypeScript has something called type definition files. Imagine jQuery, super popular JavaScript library, right? Many years, going away, but it's still there. It was written in JavaScript, and they don't have any plans to rewrite it in TypeScript, right? The question is, how can you enjoy the benefits having jQuery in your TypeScript app and having type ahead help, this autocomplete, and compiler options? Many years ago, one person created a site called Definitely Typed, and he went through, I don't remember which one was first, let's say it was jQuery. He went through all the code and he put declaration statement, declare every API. He didn't rewrite it, but he said, this is the function, it takes two arguments. The first one's supposed to be a number, and the second one's supposed to be a string. Declare, 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 declare. Now, and he started publishing these files, d.ts, with declarations. Then other people started to say, oh, I like low-dash library, I like this library, I like that library. And they started on that site publishing these type definition files. Eventually, they were moved to central repository in the Node.js community called nodejs.org. It's like Maven Central analogy in Java. There are 5,000 of those declaration files. What if you don't have it? Your particular library, maybe you are the one who created the JavaScript library and you use it for many years in your app. So what you can do in that case, you can create your own file type definition file. Actually, it could be as simple as one line. Let's say jQuery doesn't have type definition file. But we know that when you load jQuery, it creates a global object called jQuery, or you can use just a $sign. If you know the global object that is created by a specific library, maybe it's yours, what you can do in your TypeScript code, you can say declare $any. It's so-called ambient declaration. You're saying, I don't know what it is, but when the program will run, it'll be there, ambient in the environment. it'll work, but you will lose the benefits. If you never say what's inside, behind that dollar, it will not help you. But at least there will be global variable dollar, assuming that later on you will load jQuery and stuff. So it is possible.
Thank you.
All right, thank you very much, guys. Thank you.